Hi, my name is Josh, and I'm a programmer, a little bit of a science nerd. I figured I should start building up my coding resume, start getting a couple projects here and there, and what better way to kick it off than by showcasing a machine learning model that I wrote in Python that teaches my computer how to continually win a game of rock, paper, scissors with any player it comes against. So the COVID pandemic hit all of us really, really hard. At least for us common poor folk. In my case, I had no friends, no college except me due to terrible teenage boy work ethic in high school, and I had no way to make myself financially stable. I had no jobs during high school. I had that, I need some skill in order to be useful to society so I could survive. That thought entered my head. So I did what any rational, sane scientist would do. I taught myself programming languages from home, off of YouTube, and local books at the library, because that's a very good idea. The way that this model is built is in three parts. It's in the learning process, the application, and the execution. Now, in the learning process, I use roughly 1,000 control images between rock, paper, scissors, and null guess, just to give the machine learning model ample evidence and ample data to accurately produce each scenario. I know you're thinking, hold on, wait a second. It's rock, paper, scissors, but you named 4 categories. You named a null category. You're absolutely right, I did. Just to give a quick little rundown of how this machine learning works, is that you need your set of groups, your set of classifications, plus 1, and this plus 1 is always going to be a null category. Kind of. Usually it's going to be a null category unless you can offload that null into a different data type. However, in our scenario, we're going to have a null category. We have rock, paper, scissors, null. Obviously, rock, paper, scissors. But there's going to be situations where maybe I don't get to the camera in time, or maybe it picks up something a little bit wonky, alright? Let's say I'm throwing up rock, but I get to here. This obviously is not rock, nor is it paper, nor is it scissors. The computer's going to waste time, energy, and resources and throw up an inaccurate prediction as to what sign I'm throwing. That's obviously a no-no. So what we can do is by offloading it into this null category, it's going to say, hey, this is not any of this data that you want, but it's what was given to us. We're going to set it aside as category, and we're still going to run. We're going to process all this stuff, but this is a null category. This is something you can kind of just overlook and not worry about. That's why we use this. It's a very major thing that not enough computer scientists know about, that more need to learn, because if you don't have this, you're going to stress the computer out and you're going to get very, very, very inaccurate results a lot of the time. By adding in this null category, it offloads anything it's unsure about rather than having to assort it with any of your other 3 primary categories, which actually makes the computer vision model run just a little bit quicker and just a little bit more accurately, the more you know. Just to get back on track, once I was confident with the whole model, once I was confident was able to assort images into the correct category very, very precisely, I had applied it into a program. The way this program works is it takes a picture, it passes it into the model, and the model analyzes the picture and just associates it with whichever of the 4 categories, or whichever category has the highest confidence value. The confidence value is, again, how computer vision and machine learning works. It's not taking an image and saying, hey, this is rock. No. It's taking an image and saying there is roughly this % chance it's rock, this % chance it's scissors, this % chance it's paper, and this % chance it is null. Those are our confidence values, that percentage. And we're going to take the highest percentage and we're going to say that that's what it is. Is it? Technically in the eyes of the computer, no. But in the real world application, it generally is. When we have things like a 99% chance it's rock and 0.01% chance it's paper, chances are it's fucking rock. But it takes this category with the highest confidence value and it returns that prediction back into the program, and from there the computer will play the sign that beats the user. A little bit intricate, I'm very bad at explaining things, but that's how it works. The execution of the program is honestly really simple. The program is going to run and our TensorFlow algorithm is going to initialize. TensorFlow is just the Python machine learning library that holds our model pretty much. And so that algorithm is going to initialize, and when the program is ready, it asks the user if we're ready. We're going to respond with any variation of yes, or lowercase, capitals, just a letter Y, whatever. Any way that you can say yes, you can respond, and the program is going to understand what's happening. So we're going to say yes. And the program is going to count down between rock, paper, scissors, shoot. And then we're going to hold up this sign for roughly 30 seconds. Does it need to be held up for 30 seconds? Honestly, no. Because what happens next is, again, computer take the picture's going to get sent to TensorFlow, TensorFlow is going to figure out what it is and tell the computer what it is. Computer's going to play whatever beats us. Does that take 30 seconds? Honestly, yes. But the only amount of time that we need to hold up the sign for is just enough so our computer can take a photo. Is it bad to hold it up for the extra 30 seconds? No, because honestly, I don't know at exactly what point in time this takes the photo of it. So I'm just gonna hold it up for the entire 30 seconds, and voila. The computer played paper. Paper beats rock. The computer will only ever play the sign that beats you, and as such, computer vision is now automating our fun. What a wonderful world we live in. Now I understand this is a very small and dumb project, but it does use a lot of advanced skills. For example, machine learning, or computer vision to be more specific. I know I've dropped those words a lot throughout this video, and I never formally explained what they are. So according to IBM, computer vision is a field of artificial intelligence, or AI, that enables computers and systems to derive meaningful information from visual images or videos or any other visual input. Pretty much the same way that our brain and eyes work, this computer and this camera work. It's teaching our computer to have a similar relationship for visual inputs. In this situation, I did use it for a very dumb and funny joke. Oh, rock, paper, scissors. That's not a very, that's not a very business thing to do. However, the tech is definitely there, and the tech is definitely intricate enough to be used in very serious working business environments. Take a look at Tesla's Autopilot research and development. A lot of people thought it was using ultrasonic sensors or through LiDAR, but Tesla themselves have come out and said, no, we're using imaging software. We use computer vision algorithms. Take a look at OCR, or optical character recognition. It's the type of technology that lets you to mobile deposit banks. It scans the check and figures out your routing number. It figures out all of the accounting numbers, all of that just through imaging software. Take a look at Apple's Centerstage technology with iPadOS. I think it's 15. It's definitely the iPad Mini. It's very, very, very interesting. And I know these are all very big corporate things, but on a smaller scale note, small businesses can use this in a similar way that I am. On my home security system, it's a Raspberry Pi with a camera on it that runs computer vision software that can analyze and detect which of my family members come in or out of my house. Computer vision is an endless field along with machine learning because it teaches a computer how to truly automate whatever function it was designed to do. What makes a good engineer is being able to think outside of the box and being able to bridge that gap between creativity and genius. Am I saying that this rock, paper, scissors is genius? No, absolutely not. But what I am saying is that any engineer can complete a project, only a certain few can truly enjoy all of their projects or find ways to. I had to teach myself machine learning because that's just a logical progression when you get good at a programming language. I made it enjoyable for myself by making it a joke, by making it something fun, by again incentivizing myself to learn a highly advanced topic. As Einstein said, engineers create that which has never been. And I can think of nothing better than to sit back and watch an idea bridge the gap and jump between being a scribble on a piece of paper to a tangible object. I know, and I'm not trying to say that using computer vision for fucking rock, paper, scissors, I'm not saying that that's some benign, some groundbreaking new revelation. I'm not at all. But what I am saying is that the smartest engineers go outside what they have been taught to make sure that their job is done in an enjoyable way, and I think that I fit that quality, and I think I fit that classification to a T. If you're interested in any future builds or any of my robotic endeavors, feel free to take a look at JBR Industries on Instagram. It's my freelancing robotics page, and who knows, I might be returning to doing that soon, might be picking up a couple more builds here and there. Again, I do want to say my name is Josh. I do want to thank you for your time and attention, and I do hope you have a wonderful day.